Hi, good morning students. Now we are continuing the binomial theorem part. We know that NCR plus NCR minus 1 is equals to N plus 1 CR. At the same time, we discussed in the earlier class NCR divided by NCR minus 1 is equals to N minus R plus 1 divided by R. At the same time, we know this one NC0 is the same as NCN, NC1 is the same as NCN minus 1, and at the same time you also know that NCR is the same as NCN minus R. But now NCR is equals to NCS, then we can write either R is equal to S or N is equal to R plus S. And one thing you have to keep it in mind, in the binomial theorem chapter we are writing NCR. Its meaning is 0 less than or equals to R, value less than or equals to N. Now here I am saying NCR is greater than or equals to NCR minus 1. NCR is greater than or equals to NCR minus 1. Then what can you say about the values of R? Observe here, NCR is greater than or equal to NCR minus 1 means we can write that one as NCR divided by NCR minus 1 is greater than or equals to 1. From this information we can write N minus R plus 1 divided by R is greater than or equals to 1. So from this we can write N plus 1 is greater than or equals to 2R. Therefore we are getting R value less than or equals to N plus 1 divided by 2. And again another point here, NCR can be written as N by R into N minus 1 C R minus 1. That means suppose we have 10C8 is there, that can be written as 10 by 8 into 9C7 we can write. So how can we write this one? Observe here, we know the formula for NCR. NCR can be written as N factorial divided by N minus R factorial into R factorial. So N factorial can be written as N into N minus 1 factorial divided by R factorial can be written as R into R minus 1 factorial. By observing this R minus 1 factorial and N minus 1 factorial, how I am going to modify this N minus R factorial as N minus 1 minus R minus 1 factorial. Right, now this is N and here R, we can separate it, that we can write it as N by R into N minus 1 C R minus 1. So that's why NCR can be written as N by R into N minus 1 C R minus 1. Now tell me what we can write N plus 1 C R plus 1, that we can write it as N plus 1 divided by R plus 1 into N C R. What we can write 20C18. 20C18 can be written as 20 by 18 into 19C17, right? So another idea we are going to discuss here, greatest binomial coefficient. What is greatest binomial coefficient? I hope so you know what are the binomial coefficients. Observe here, NC0, NC1, NC2, NC3 and so on, NCN. These are called binomial coefficients. Among all these binomial coefficients, which is the greatest binomial coefficient, that we have to find out. Just observe here, we know 4C0, 4C1, 4C2, 4C3 and so on, 4C4. 4C0 value 1, 4C4 also 1, 4C1 is equal to 4, 4C3 also 4, 4C2 value is equal to 6. This is greatest among all these binomial coefficient. Suppose you see 6C0, 6C1, 6C2, 6C3, 6C4, 6C5, 6C6, 6C0 value, 6C6 value 1, 6C1 value, 6C5 value 6. Now what about 6C2 value? 15, because you know 6 into 5 divided by 2 factorial. So that's why you'll get 15. 6C4 also 15, whereas 6C3 is equals to 20. This is the greatest binomial coefficient among all these. So observe here, in case of odd number, 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, 5C0 value, 5C5 value 1, 5C1 is equals to 5, 5C4 also 5, 5C2 is equal to 10, 5C3 also 10. In case of odd, there are two coefficients are greatest. Those are 5C2 and 5C3. Just in case of even, you can observe 4C4 by 2 is the greatest binomial coefficient, or 6C 6 by 2 is the greatest binomial coefficient when n is even. That's why when n is even, NC n by 2 is the greatest binomial coefficient among all these. Whereas here you can observe 5C 5 minus 1 by 2 comma 5C 5 plus 1 by 2. These are the greatest binomial coefficients in case of odd. That's why when n is odd, we can say NC n minus 1 by 2 comma NC n plus 1 by 2. These are the greatest binomial coefficient when n is odd. Whether n is even or n is odd, middle term coefficient, this is the middle term. These are the middle terms, because when n is odd, there are two middle terms. Middle terms coefficients are the greatest among all binomial coefficients. The next idea we are going to discuss is numerically greatest term. So what is the meaning of numerically greatest term? In the expansion of 1 plus x whole to the power of n, total we have n plus 1 terms are there. Among all these terms, which term has numerically greatest value for some positive real number, for some real number x, where n belongs to natural number? So what is the meaning for numerically greatest term? We are saying rth term is the numerically greatest term, means that term is always greater than or equals to all ti. That means for I is equals to 0, 1, 2, 3 and so on n plus 1. Ti is always less than or equals to tr. Then we can say rth term is the numerically greatest term in the binomial expansion of 1 plus x whole to the power of n when n is a positive integer. But for finding the numerically greatest term, what we are going to do is n plus 1 into mod x divided by mod x plus 1 value we will find out. N plus 1 into mod x divided by mod x plus 1 value we will find out. If this value lies between m and m plus 1, where m is an integer, if that value lies between m and m plus 1, then I can say m plus 1th term is the numerically greatest term. Suppose we are getting this n plus 1 into mod x divided by mod x plus 1 value, exact integer we are getting m. Then we can say mth term and m plus 1th term. These two terms are numerically greatest terms. Suppose I found the value of n plus 1 into mod x divided by mod x plus 1. Suppose this value I got some 7.79. That means this value lies between 7 and 8 or not. So we can say 8th term is the numerically greatest term. Suppose we are finding n plus 1 into mod x divided by mod x plus 1 value we are finding. That value we got exact integer 8. Then I can say 8th term and 9th terms are numerically greatest terms. So we will continue the discussion with a few applications based on this numerically greatest terms. So now in this expansion 1 minus 5x whole to the power of 12, we have to find out the numerically greatest term when x is equal to 2 by 3. Come on, find out n plus 1 into mod x divided by mod x plus 1 value, find out. Now that is nothing but 12 plus 1 into mod x, that is nothing but minus 5x, right, divided by modulus of minus 5x plus 1, because in the expansion of 1 plus x whole to the power of n we discussed the idea, that is n plus 1 into mod x divided by mod x plus 1. Now here in place of x we have minus 5x, that's why. Now we can write further this one as 13 into 5 into 2 by 3 divided by 5 into 2 by 3 plus 1. That can be simplified further as 130 divided by 13, that is equals to 10. Exact integer we got. Then I can say 10th term and 11th terms are numerically greatest term in the expansion of 1 minus 5x whole to the power of 12. Come on, tell me what is the 10th term? That is 12c 10th term. 10th term is nothing but t9 plus 1. Yes or no? That is equals to 12c9 into minus 5x whole to the power of 9. Next 11th term t11, that is nothing but t10 plus 1, that is equals to 12c10 into minus 5x whole to the power of 10. Now either here or here, in place of x we have to substitute 2 by 3, so we will get the value of the numerically greatest term. So from this information we are able to say which terms are numerically greatest terms. After finding which term is numerically greatest term, so this is the way for finding numerically greatest value, right? Now this is another question, 3x minus 5y whole to the power of 17. That we can write it as 3x into 1 minus 5y divided by 3x whole to the power of 17, right? So that can be written as 3x whole to the power of 17 into 1 minus 5y divided by 3x whole to the power of 17. Now it is in the form of 1 plus x whole to the power of n. Now I find out n plus 1 into mod x divided by mod x plus 1 value, find out. That is equals to 17 plus 1 into modulus of minus 5y divided by 3x divided by modulus of minus 5y by 3x plus 1. But he has given the values of x and y also. So 18 into 5 into 2 by 7 modulus is there, that's why we can forget about the symbol minus. 3 into 3 by 4 whole divided by, so 10 by 7, 9 by 4 plus 1. Now that further simplification we can do it as 18 into 40 divided by 63. Yes, this simplification is 40 divided by 63 by 40 divided by 63 plus 1. Now that further simplification, 720 divided by 103. Check this simplification, you will get 6 point something. 720 divided by 103, you will get 6 point something. That means we can say this value lies between 6 and 7. That is lying between 6 and 7. Then we can say 7th term is numerically greatest term in the expansion of 3x minus 5y whole to the power of 17. So here you find out the 7th term. 7th term is nothing but t7, that is equal to t6 plus 1. that is nothing but 17c6 into 3x whole to the power of 17 minus 6 into minus 5y whole to the power of 6. Now in place of x 3 by 4, y is equals to 2 by 7, substitute, you will get the value of the numerically greatest term, but seventh term is the greatest term. If you substitute the values in the seventh term, you will get the numerically greatest value. So there are few problems we will discuss based on the remainders. 2 power 2009 is divided by 17. What is the remainder? So first of all, observe here, 2 power 2009 can be written as 2 into 2 power 2008. Now this can be written further as 2 into, now 2 power 2008 can be written as 2 to the power of 4 whole to the power of 2008, 502, right? So now this can be written as 2 into, sir, what is the advantage? The advantage is 16 can be written as 1 minus 17. That's why this is 1 minus 17 whole to the power of 502. If you expand this one, what happens? This can be written as 502C0 minus 501 into C1 plus, 501C1 into 17, next plus 502C2 into 17 square minus 502C3 into 17 cube plus and so on. Finally 502C502 into 17 power 502. Observe here, except the first term, in all other terms there is an involvement of 17. Except the first term, in every term there is an involvement of 17, right? So I can write this one as 2 into 502C0 value is 1 plus 17 into some integer we can write, because this from all these terms we can take 17 common. That's why 17 into some integer we can write. Now this is equals to 2 plus 17 into 2m. Now tell me, when it is divided by 17, it is exactly divisible. What is the remainder left here? 2 is the remainder. That's why 2 power 2009 is divided by 17. We will get the remainder as 2. That is the way to proceed this type of question. So observe here, 2 power 2006 plus 2007, when divided by 17, what is the remainder we will get? Now what I am doing is, this 2 power 2006 can be written as 2 to the power of 4, same, because we are expressing in terms of 1 minus 17. 2 power 4 whole to the power of 501. Yes, because it is not divisible by 4. So we can write this one as 2 power 4 whole to the power of 501 into 2 square plus 2007. Now again we can write this one as 4 into 2 to the power of 4 can be written as 1 minus, or not 1 minus, we can write this one as 17 minus 1 whole to the power of 501, because in the earlier discussion the power is an even number, but now the power is odd number. That's why 17 minus 1 whole to the power of 501 plus, how can we express 2007? That can be written as, we have how many times it will be divisible with 17? Just that can be written as 17 into 118 plus 1 we can write, right? Next, this can be further simplified as 501C0 into 17 power 501 minus 501C1 into 17 power 500, right? Plus 501C2 into 17 power 499 minus and so on finally minus 501 C 501 into, that's all. Okay, I will write one more term here. 501 C 500 into 17 minus 501 C 501, right? That is the term, the expansion of 17 minus 1 whole to the power of 501 plus 17 into 118 plus 1. Now observe, except the last term, in every term there is an involvement of 17. That's why we can write this one as 4 into 17m minus 1, because you know this value is equals to 1, plus 17 into 118 plus 1. Now further simplification, we can write this one as 4 into 17m plus 17 into 118 minus 4 plus 1. In all these terms there is an involvement of 17. That's why we can write 17 into alpha minus 3. So when it is divided by 17, remainder, can you say minus 3? No, remainder never be negative. That's why further simplification I am doing here. 17 alpha minus 3, right? So for that what I am doing is subtract 14, add 14. Now this becomes 17. We can mix with this. So 17 into alpha minus 1 plus 14. So this is exactly divisible by 17. We are getting the remainder as 14. So this is the next question, is asking 5 to the power of 99 when divided by 13, what is the remainder? So we have to think how to express this 5 power 99 in terms of 13 or 26 or 39, like that, because in 13 there is an involvement of 13, in 26 also there is an involvement of 13, in 39 also there is an involvement of 13. Now you can stop your discussion here. The reason is 5 square is equals to 25. 25 can be written as 26 minus 1. That is the idea in approaching this particular question. Now what I am doing, observe here. 5 power 99 can be written as 5 into 5 power 98. That can be written further as 5 square, that is nothing but 26 minus 1 whole to the power of 49. Now you know this expansion, 5 into 49 C 0 into 26 whole to the power of 49 minus 49 C1 into 26 whole to the power of 48 plus 49 C2 into 26 whole to the power of 47 plus and so on, minus and so on. Here you will get minus 49 C 48 into 26 plus you will get minus the last term 49 C 49. That is the expansion of 26 minus 1 whole to the power of 49 by using the binomial theorem. Now what I am doing, observe here, except the last term, in all other terms there is an involvement of 26. That's why we can write that one as 26 into alpha minus 1. Again we can write this one as 5 into 26 into alpha minus 5. Same explanation, we can't write this one as remainder as 5 because the remainder never be negative. So that's why what I am doing is this is equal to 5 into 26 into alpha minus 5 minus 8 plus 8, because this can be expressed as in terms of 13. Now from this entire term we can take 13 common. If you take 13 common, we are getting 10 alpha minus 1 plus 8. It is exactly divisible by 13. So we are getting the remainder as 8. So this is the particular question. 19 power 93 is divided by 81. What is the remainder? That's why immediately we have to think this 19 we have to express in powers of 9 or 18 and so on. Yes, observe here. There ends our discussion. 18. Why? 19 can be written as 18 minus, 19 can be written as 18 plus 1 whole to the power of 93, right? Now that further expansion we can write this one as 93C0 plus 93C1 into 18 power 1 plus 93C2 into 18 square plus 93C3 into 18 cube plus and so on 93C93 into 18 power 93. Sir, why you express it in terms of 18? Just check from here onwards. 18 square means what? 2 into 9 whole square. That means 9 square is 18 or not. That means from here onwards, in every term, there is an involvement of 81 from here onwards. Right? So that's why we can write that one as 1 plus 93 into 18 plus we can write that one as 81 lambda. Sarmar, what about here? Here only 9 is there one time. So we have to search for the 9 other time, one more time here. 1 plus this 93 can be written as 90 plus 3 into 18 plus 81 lambda. So we can write this one further as 1 plus 90 into 18 plus 54 plus 81 lambda. Now here already one time 9 is there. One more time also 9 you will get. That's why 1 plus 54 is 55 plus from this we can take 81 common. You will get here lambda. Here also we are taking 9 common, right? Then what happens? So 9 come outside. Then we will get here 2 left. Here 10 left. That's why we are getting 20. Now when it is divided by 81, we left with the remainder as 55. See these two questions. 50C4. If you expand this sigma, what happens? R is running from 1 to 6. Substitute 6 here. You will get 50C3. Next substitute 5. 51C3. Next 52C3. Next 53C3. Next 54C3. Finally, when R is equals to 1, we will get 55C3. Now, according to the formula NCR plus NCR minus 1, we can write N plus 1 CR or not. Then NCR plus NCR minus 1, we can write N plus 1 CR. Again, observe here. NCR plus NCR minus 1, we can write N plus 1 CR. Again observe here, these two sum, we will get N plus 1 CR. Again you can observe these two sum, you will get 54C4. This is again NCR plus NCR minus 1, you will get 55C4. Again these two sum, you will get the answer as 56C4. That's why this total value is equals to 56C4. When this type of order is there, this 6 directly add here. 50 plus 6, 50 plus 6 C4, that is equal to 56 C4. Directly we can write the answer. Now see the another question. This is the another question given in previous JEE exam. The question is given in this way. Summation I is equals to 1 to 20 20ci minus 1. According to the earlier discussion, this we will call it as a Pascal's identity. NCR plus NCR minus 1, we can write it as n plus 1 CR. So what the numerator becomes? The numerator we can write it as 21ci. Yes or no? NCR plus NCR minus 1, we can write n plus 1 CR whole cube. As I discussed in the beginning of the class, NCR we can write it as NCR can be written as n by r into n minus 1 CR minus 1. That's why we can write this one as summation I is equals to 1 to 20 ci minus 1 divided by, that can be written as 21 by I into 20 ci minus 1. Now 20 ci minus 1, 20 ci minus 1 gets cancelled, right? So then what left? That is equals to sigma I is equals to 1 to 20. 1 by 21 into I, that means I by 21 whole cube. That further we can write it as, if you take 1 by 21 cube, yes or no, 1 by 21 whole cube will come outside. That summation expansion you will get 1 cube plus 2 cube plus 3 cube plus and so on plus 20 cube. Sum of the cubes of the first 20 natural numbers you know, that is equals to n square into n plus 1 whole square divided by 4. That we are getting 100 divided by 21. That is given in the question as k by 21. So the value of k is equals to 100, right?